Hello, everybody. Very good to be with you here this afternoon. So we are going to talk about SCTE-224. Quick agenda. So we'll look at the principle of SCTE-224, the data model. Then we'll go over how we can use in-band signaling, namely SCTE-35, as a companion to 224 to complement it, if you like. And then we'll look at a real deployment that Harmonic is involved in for distribution of broadcast channels to OTT streaming platforms that implements SCTE-224 and 35 together. And then we'll look at some evolution of the standard because there was a very recent new release of the standard back in March, and so we'll go over that a little bit. Okay, so if we look first at the transition, that's happening for linear television, obviously, we're moving from a set-top box and TV-based experience where you are receiving that, over the air or via a pay TV network to a world where mobile viewers are watching channels on many different devices over many different OTT delivery platforms. That can be the new skinny bundles. That could be, a direct-to-consumer app. That could be also a pay TV operator that does an OTT app, or that could be TV everywhere. All of that is available today. And so as a consequence, programming rights needs to be managed across all those delivery mediums so that, if you'd like, the equation of who's watching, where, and on what device is always resolved. So the channel providers, to do that, they have to generate sophisticated content access rules and deliver them to their distribution partners. So who, where, on what device. So you need rich and standard-based metadata to do so in order to drive what I call programmatic decisions, in the distributor's OTT platform. So, what used to be static is now much more complex, but still you need to resolve those rights. So enters SCTE-224. So real quick, the principle is that, define a web-based interface, SNI for event scheduling notification interface. With that, content provider communicate schedules content policy to distributors. A policy enables the content, distributed to audience to be controlled based on attribute of that audience, including geographic location, device type, etc. So that's the principle. And what we're going to do next is look at how it works, the data model, etc. But first, this is an implementation scenario. So you see, that's what I call the 224 in the linear channel life cycle. So one scenario is the content provider, that sends SCTE-224 schedule. That's what you see at the bottom. So the schedule and the policies out of band to the distributors. That happens before airtime. And then you have, SCTE-35 that is, sent together with the video content in real time. So a policy that you send at the bottom applies to a piece of programming that is identified by a unique content ID. And then, in the SCTE-35, you provide the content ID as well as some default restrictions, okay, for all the pieces of programming that make the linear channel. What's interesting and nice is that it keeps the traditional demarc, if you'd like, between the content provider on the left and the distributor on the right, but it goes much beyond what traditionally was controlling an IRD and doing a blackout. Now you can do much more sophisticated rules. So this is kind of an eye chart, but you'll be able to look at the slides later in more details, but this gives you an overview of the SCTE-224 data model. So we're going to start on the left, with the media. So you have a media element, which basically represents the TV channel or programs in the channel. And the main purpose for the media element is to carry media point. The media also has a source, URI that points to the content, for that media. So if you look at the media point, basically it's a point in time in the linear channel, okay, inside the media. And when you think about it in the context of a channel schedule, basically the schedule is made of programming segments, interstitial segments, right? And what is likely is that the policies about consumption of the content are likely to change at segment boundaries, segment between programs again or interstitials. And so media point, it identifies such a segment boundary and applies or removes a policy at that particular point in time. So we'll see with in-band signaling how you can accurately, point to the media point. And then basically in the media point, you have some IDs, you have some metadata to describe the media point. But the key thing is that you apply a rule, a policy, and the policy, as you will see, connects together audiences and action. So first, let's move to the right now and look at the audience. So the audience is a set of characteristics or attributes that define a set of users, okay? It could be characterized by the geography, like a home zip code or geolocation, when you're watching content. Or it can be also defined by the type of device or specific capability of the device, all right? So that's my audience on the right. It's fairly generic, but the idea is to define the attributes of a set of users or devices. And then you have the viewing policy that puts together that audience, a audience with some actions. So the actions can be a new content, alternate content, okay, specific to that audience. So I'm on a cell phone, I cannot watch the content, but I'm going to be redirected to an alternate content. Like I said, a little more sophisticated than just a blackout. It could be also that you define in the action rules for fast forward, rewind, capture, to specify the time-shifted attribute or replay TV attribute of a specific piece of programming. So in essence, applying a viewing policy amounts to specifying actions to be taken against a particular audience that wants to access the media, starting from the media point onward, okay? And the action themselves are very likely to happen in the OTT platform. So if we look back here, that OTT platform on the right, that's where the action will take place. So the next part here is to talk a little bit about in-band signaling. So SCTE-224, out-of-band distribution. And then as a companion or to complement it, it's good to use SCTE-35. So some background. It's a very accurate in-band triggering mechanism. It's been used for 20 years, mostly for cable ad insertion. But beyond ad insertion, beyond what is called the splice insert command, there is also something that is called time signal that provide extensibility beyond splicing with the same accurate timing. And I would say that in the past 8 years, really with time signal and what is called segmentation descriptors, SCTE-35, has been rejuvenated, if you like, and it's very relevant for multi-screen and OTT streaming application. So from a high level, what you do is you use SCTE-35 segmentation descriptor to signal accurately in-band every single piece of programming and interstitials that make the linear channel, okay? So you have SCTE-35 markers, and you try to cover every single thing that can happen, during a broadcast day in the life cycle of the channel. Even unscheduled events, okay? Something that is not part of the normal schedule, even that, you want to be able to mark and signal it in-band. So what I show here, again, it's too small, I apologize, but you have your program, with program start, program end, but at the sub-level, you have chapters for a given program, start and end. And then you have break, start and end, interstitial, so different ads, different promos, and you can also signal placement opportunity. So a provider can have a break, multiple ads inside that break that would be marked by a placement opportunity. That's an important one. And then you could have also distributor, placement opportunity, sometimes referred to as a veil for local ad insertion or dynamic ad insertion now in the OTT world. So all of that you can signal, with SCTE-35. One of the important things that you do is that, of course, it's very accurate, because it's in band with the video itself. But you can define, and it's important to define unique identifiers for the programs and the ads. So you put, those identifiers in the SCTE-35 segmentation descriptors. And then you have also, placeholder in the payload. You can put some simple metadata for restrictions, default restrictions. You could do a scheme where it's only SCTE-35. If you combine together 35 and 224, the 35 typically becomes the default. But if you find a matching policy, for a given piece of content based on the content ID, then you apply the 224. The 224 supersedes. So the scope of 35 with segmentation descriptors, that's not just for multi-screen. But I would say that in the new OTT world that we described initially, where anybody can watch anywhere on any device, and you need to know the user's identity, location, device, et cetera, that provides a very efficient way to distribute accurate in-band metadata, and that metadata more and more will be critical. Quickly, so what we show here is how the two work together, 224 and 35. So two ways that you can use 224. On the right, that's in the media point, you can put a match signal, okay? And the match signal is a mechanism by which you assess a logical expression. So rather than go into the theory, typically you saw how you can define a program start before. So the match signal condition could be if in band I see a program start with a with a program ID, of XYZ12345. That's my match, and I'm going to apply a rule. Or if it's the end of such program, I'm going to remove a rule, okay? So that's nice because, like we said before, with 35, you have very good accuracy, and you can point exactly to a boundary or program start, program end, and apply the rule exactly, at that boundary point. So you don't need the match signal to use 224. Let's say that you don't have 35. You can use what is called a match time. In that situation, your 224 becomes straight schedule, and based on time, you can apply and remove policies. But the risk when you do that, as you know, when you distribute compressed video, usually through multiple stages, you're going to have some buffering and delays. So you have the risk with the match time of loose accuracy. When you go with the match signal and the 35 coming in band, then you can achieve very good accuracy up to exact frame accuracy. So when you use them together, okay, benefits again, accuracy with the PTS in the 35. And also, this is very important. In unscheduled situations, like breaking news, or let's say you have a game overtime, right? Well, you can implement your system so that the SCTE-35 markers will dynamically follow the moving boundaries, of your broadcast event. Of course, it's not magic, you need some work there. So that has to do with system integration into a broadcaster's environment, tying all the way up to the automation systems. But if you do it, you can achieve this. And again, have your in-band metadata follow dynamically even for unscheduled situations. Ultimately, if you don't do that, you're going to run into situation and problems, especially with live games. And so it's strongly recommended that you have a way to achieve this so that your OTT service is viable and also to provide a better end-user experience. So now we're going to review an actual deployment for distribution of broadcast channels to OTT streaming platforms that implement both 35 and 224. So first, because 224 is a scheduling interface, you need to manage schedules. When you generate SCTE-224, you need to manage schedules. So in that architecture here, Harmonic provides a cloud scheduling SaaS, if you like, that does a bunch of things. So first, it imports schedule from many different sources for all those channels that are broadcast affiliates on the left. It can be local traffic, can be a listing service, it can be a program manager from the national broadcaster if we're talking about regionalization here. And so we normalize all the schedules. In particular, like I said before, it's very important to define unique IDs, for your programming. So we assign unique IDs to all the programming pieces that make the linear channels. And then we add OTT restrictions. You see the web client in blue here. What it does is, in case some of the content programming for the channel that typically go over the air, but now you're trying to move them to over the top, if some programming is not cleared for streaming, you need to enter restrictions that today don't necessarily exist in systems. So when you do imports, you might import only over-the-air rights. So you need to edit those rights for streaming. So that's what we do with that web client. Now we got complete schedule, normalized OTT restrictions, and so we either generate 224 directly, or we can also export to an SNI system if the national broadcaster has its own SNI system to create the 224. So beyond the scheduling, of course, now there is what happened in real time, okay? Because the 224, like I said, it's out of band ahead of airtime. And then what you do is here everything that's real time. So you have a software appliance at each of the affiliates on the left that does transcoding first. So here, it's a US broadcaster deployment, so it's MPEG-2 transcoded to MPEG-4 to feed better over the internet. And then what we do is that we send the linear channel to the cloud. And in the cloud, we do decoration, meaning SCTE-35 insertion. The software appliance also ties to the automation and bridges or translate, if you like, the automation command to the cloud so that we can do the SCTE-35 insertion based on accurate automation commands. And like I said before, that's also how you can cope with unscheduled situations. If you have an overtime, the automation will just delay the next program start, right? And also if you want accurate break signaling, that's how you do it, by the tie to the automation all the way to the left. So we do the decoration, the SCTE-35 insertion, and then we distribute to all the virtual MVPDs on the right over the internet. So you have a fully decorated transport stream, and then out of band you have the 224, and the OTT platform kind of closes the loop, receiving the TS with the SCTE-35, the content ID on one end, and matching those content IDs with media point in the 224 and applying the rules that match the media point, applying, removing rules based on the schedule. So just this is real. 200 affiliates. We've been doing that for the past year, and so that's a very good example of how you can adjust to the OTT streaming conditions with 224 and 35. And I would say that if you didn't have those tools, it would be very difficult. Because again, US broadcasters, the main HD channel is a mix of primetime content, syndication, sports, news, and there's a lot of variation in terms of the rights for all those different program elements. Not mentioning the fact that you want to provide also accurate signaling for dynamic ad insertion in the OTT platform as well. All right, so evolution and improvements of SCTE-224. So like I said when we started, the standard is fairly new. The first version I think was 2015, but there was a brand new release in March, this past March, 2018, trying to improve on several fronts. So first, it adds the new release more definition around the metadata that can be used to describe many of the SCTE-224 elements. We saw the data model before it was wide open. And the problem when it's too open is that basically the risk is what I call proprietary implementations. So in the new version, There is definition around the metadata. They follow some specific namespace, or they follow another SCTE standard 236. You can still use proprietary. I'll come back to this, but it's constrained a little bit more compared to the first version of the standard. Second one, important one, the reusable media point. So what is that? This one was a headache until this was introduced. That means that before, when a media point was applied, it was applied once and then discarded. You could not reuse a media point as in a resident one. So think about it. If I have a rule that's going to apply all the time for my channel, I'd like to be able to have a kind of resident policy attached to a permanent media point. But you couldn't do that with the first version of the standard. So you would need to resend the rule over and over again every time you apply it. So that was kind of pain in the butt. So anyway, now it's fixed. There is that notion of reusable media points, which translate into the possibility to define resident policies that last forever. So that's a big improvement. Priorities among policies. So that's another thing that's new and good. Now you have priorities. So if you have policies that are active at the same time, you can prioritize among them. And last but not least, kind of touching on the first point, the new version really recommends that providers define an implementation's user guide. So what is that about? Because it's still wide open, okay, very open for a standard. So the idea here is that content providers, they provide a user's guide on all the options that they select, all the metadata schemes that they implement, so that you try to have first some commonality, hopefully, and then guidance to the OTT distributors that will have to receive from many different content providers. Think about it. Here we're talking about that deployment I was showing you, one big broadcaster, but you have many like these. So if you are a distributor, an OTT distributor, a virtual MVPD, you're going to receive from many of these. So you could receive many different SCTE-224. And if those SCTE-224 are different because of the metadata or options that you implement, it's complicated. So we're trying to get better description and hopefully also better commonality among the implementation on the content provider side. Some conclusion. So SCTE-224, it has the potential to address both the content right issue, but also better monetization, with dynamic ad insertion, and can drive really the content manipulation in the OTT platforms. The main channel is accurate delivery of SCTE-35 signaling on one side, and then harmonization so that you avoid what I was describing just before, having SCTE-224 data stream that have nothing to do with one another, and then the OTT providers don't know how to implement those content rules. If you want SNE to become a widely adopted standard, and by the way, also internationally, not just in the US, which is today what's happening. Today it's mostly in the US. We need that commonality. We need that guidelines on how to implement the standard. With that, any questions?
We've got time for one or two questions. I'll bring the microphone up.
You mentioned breaking news as an example,
yes.
So which is more granular than just a playout,
yes.
Scheduled playout. So with breaking news, let's say you have a half-hour newscast,
yes.
and some of the content is embargoed. Let's say you live in a large demographic, NFL footage can't go over the OTT.
Yes.
Now I want to use the dynamic ad insertion platform,
yeah.
not just for ads, but for content replacement.
Yes.
So would you use SCTE markers in there to delineate, but
yeah.
the 224 for a different schedule of what to use for replacement?
So you have two options because we're dealing with this. So let's say that your example is good. So you are into a content that is embargoed for most people or some people, categories of devices or people, etc. then you go into breaking news, and obviously you want the breaking news to be watched by everybody. So you need to change the content rules, okay? So you can either send new SCTE-35, okay, with new content ID, and then map that to a resident policy that is ready to go all the time that matches the breaking news. And that resident policy will say it's open for everybody, okay? Or you can, in real time, send new SCTE-224 for the same content ID. So you don't change, the content ID now. You keep the same content ID, but you change the rule.
Right.
It's fairly logical. Both are being tried. And so before, again, we didn't have a choice because we couldn't do resident policies. So we couldn't change breaking news as a new content ID and hope to match that to the resident policy. Now we have that with the new standard, but it's going to take time for the SNE platform on the OTT side to implement the new standard.
So any particular preference? Have you done any
in terms of latency? In terms of latency, what seems to be the more efficient is to have the resident policy always ready to trigger. Right. And just send a new content ID in SCTE-35. That seems to be the most efficient way.
We have time for one more.
Okay. For the restriction that you mentioned on
for
the web restriction.
Yes.
What is the difference between whatever the SCTE-224 allowed compared to an APG where we have a blackout proxy?
So first of all, an EPG, can be based on 224. You can, once you receive 224, you see some of the OTT provider, the new skinny bundle people, they use that also to drive their EPG, okay? So it's not like they are separate. Again, SNE, even scheduling notification interface, it's a scheduling interface, at the core. So you can use that to create your EPG grid. Okay. And last year, I remember Hulu at the keynote was explaining that they had the grid based on 224, and then they were using 35 to kind of update in real time the duration of live events and to adjust also the blackout or content replacement conditions using the combination of the two together. Okay. So it's not one or the other. I mean, SNE 224, it's really a scheduling interface.
Just an extension on the question. If we have to go a little bit lower than, because you had the OTT platform before the CDN, but if we want to have a geo-targeting and go up to a certain level, so what will be?
So most, if you look at, let me go back real quick. We can look at this. So that's the OTT platform here on my generic diagram. In there, you have typically what's called a manifest manipulator. Okay, so based on who's going to make the request for the content, what device is going to make the request of the content, the manifest manipulator is going to be the one serving the final manifest and providing either a slate if it's embargo, content replacement if you cannot access the content, or letting you access the original content if you're clear to do so. It's also the same manifest manipulator based on if you're doing the dynamic ad insertion, targeted ad insertion, could be serving you, different ads during a break or different break altogether. So that's in there. That's what I said before. In that OTT platform, you have a manifest manipulation piece that will be the actual,
But with the CDN, it's cached. So that means the CDN tiers, they will have the same manifest.
But the manifest is not cached. I mean, the content is cached, but the manifest has to go, if you implement this type of content manipulation, you need to go back, at the source. Yes.
So the manifest
yes.
always.
Yeah.
Thank you.